Hello friends, my name is Bilal Khan and today is another topic of the Rust book, that is basically the ownership. So let's go to the screen and I will show you there. So here you can see here that I'm present in this chart, but before going to the ownership principle, let's discuss some of the memory allocation, that what are the memory allocations and how are they used so in the operating system. So first of all, let's take a look at the first memory allocation, that is the stack. So if I write this like this, so stack memory. So yeah, this is the stack memory that can be used in the operating system, in which what it will do, basically it will take the data one by one and it will create a stack of the data. So what does it mean? Basically, let's say if you have this data, this is your first data that you have inserted in a variable. Now after that, if you want to add another variable, you have to put above it like this. And then if you want to add another variable, you have to put above this. And then similarly, if you want to add further data, you have to above this. So this will be like a stack of books in which you will be placing one after the other. This will be the stack memory allocation, in which you will be adding the data one after the other, and it will make the process easier. Why? Because let's say if you want to take any data, let's say if you want to take this data, then what you need to do is to first of all take this data, then if it is not matched, then take this data. If it is not matched, then take this data, and if it is matched, then it will stop there and it will not take all of these data, right? So it will take the data from the above, and after that it will go inside it, and if it is not matched the condition, then it will go further inside it and it will take this data and it will stop the execution, because the other data is not required to be fetched, because the third data is fetched and that was fulfilling the condition. So yeah, this is the stack memory allocation, and basically it saves the time. It is easier and fast as compared to the heap memory allocation that I'm going to be discussing later on. But first of all, you need to understand that what is stack memory allocation, in which there will be a stack of data, or just like a stack of books that will be placed one after the other. And if you want to take one book, then you have to start from the above, and then after that you have to start from the if the first book is not found, then you can take the another, and then you have to take the another. So this is the point that you need to keep in mind. You cannot take the data from like the middle or from the like below. Instead, you have to follow the process by starting from the above stage, and then you have to dig deep dive into it and take the data at the end. So I hope you understood. And another point that you also need to keep in mind is that it is following the principle of LIFO. So what does it mean? So LIFO means last in, first out. So last in, first out means that the last data that was inserted. So what was the last data that was inserted? So let's take a look at them. So you inserted this data at first, and then you moved to this one, and then you moved to this one, you inserted this data, and then you inserted this data, and then you inserted this data at the end. So this data is the last data that you inserted, and this is the last in or the last inserted data. So as a result, you have to take this data at first, because if you want to take this data, then you can't take the data from the bottom, or you can't take the data from the middle. Instead, you have to take the data from the above, and that is the first data, right? So the last inserted data that you inserted from the above to this one, this was the last inserted data. Now you have to take this data first. So I hope you understood. So the last there is if you like if you reverse this, it will be like this, FILO, like first in, last out. This is also the principle that you need to keep in mind. Basically, this what it says, first in. So what is the first data that was inserted? This one. So if this data is first inserted, then it obviously will be pulled at the end. So you first of all, you have to take this data, then you have to take this data, then you have to take this data, then you have to take this data, and at the end you have to take this data that will be out. So the first data that are inserted, like you inserted the data from here, that data will be the last data to be out. So yeah, I hope you understood that what the stack memory allocation is and how it is following the LIFO or the FILO principle in order to take the first, in order to take the last data first and in order to take the first data last. Yeah, that's the stack memory allocation. Now let's take a look at the heap memory allocation. So if I name this heap memory, so yeah, this will be basically what is called here. So this is not in a stack based in which the data is assigned properly in a proper manner. Instead, here the data will be distributed anywhere. Here is the data 1, here is the data 2, here is the data 3, 4, 5, sorry, like this. So this is the random data that is put here, and basically what it does, it will contain a lot of data. And in the stack memory allocation, you need to keep one thing in mind, is that it has limitations. It means that it cannot store further data, it cannot store out of limitation data that it has. But in the heap memory allocation, it has no limitation, in which you can store a huge amount of data without any kind of limitation. So this is the upside of it, and this is the downside of the stack memory allocation. But the heap memory allocation has a downside also, in which it will take a lot of time in order to take the data. In the stack memory allocation, we have discussed that it will take the data easily, first of all it will take this, and this. But the heap memory allocation, basically what it will do, it will find all of the data one by one in order to fulfill the criteria. Let's say if I want to find the variable x, then what it will do, it will first look at this one, the variable x is not found, then it will move to this one, then it will move to this one, then it will move to this one, and at the end, if it found the variable x, then it will stop here. So what does it mean? It means that it has to go through all of the data in order to find the desired data or the required data that is required from the user. So yeah, it is slow, but it will contain a lot of data, but it is fast. But the downside of it is that it contains not that much data. Instead, it has some kind of limitations. So I hope you understood that what is heap memory allocation and what is stack memory allocation, in which the data will be stack in a proper way, but the heap memory allocation will not stack the data, in which you have to find all of the data in order to at the end you have to find the required data. But first of all, you have to go through all of the data at first. So yeah, this is the heap and the stack memory allocation. I hope you understood. Now there is a now let's go to the ownership principle that is basically that will be used in the heap memory allocation. All right, so the ownership principle that I have told you in the in the starting of this video, that it will be applied in the heap memory allocation, it will not be applied in the stack memory allocation. Why? So let's write ownership principle won't be applied in the stack memory allocation. Instead, it will be applied in the heap memory allocation. Right? So why it will be applied here in the heap memory allocation? Because the heap memory allocation does not have any kind of limitation. So the chances are, if you declared any kind of variable, the chances are you can misuse this variable, or you can use this variable further also. So this is the that's why the ownership principle will be applied here, in which if the ownership is transferred, then that variable will not be used further. So I hope I will be talking about later on in this video, but first of all, you need to keep this in mind, that the ownership principle will be applied in the heap memory, but it will not be applied in the stack memory, because the stack memory has a fixed size, but the heap memory has not a fixed size. So in case if the variable or the data can be misused, or it can lead to the memory allocation problems that the ownership principle is solving. So from this, I hope you understood. Now let's take a look at that, where the stack memory allocation values will be used in which kind of data types. So stack, well, let's remove this, like primitive data types like integers, float, boolean will be present in the stack memory. All right, so these are the integers, float, boolean. These are basically the fixed value. So the integers could be having like 8-bit values, or the 16-bit values, 32-bit values, and the 64-bit values, and like 128-bit values. So it means that they are fixed, so it cannot be increased afterwards. But what you can say, the string, or what you can say string, vectors, box. So these are some of the custom data types that will basically be using the heap memory allocation. Why it will be using the heap memory allocation? Because they don't have any fixed size. Like the vectors can be increased, the strings can be increased or decreased. They don't have any fixed size, so that's why they will be used in the heap memory allocation. And on these what you can say, on these variables, the ownership principle will be applied, like in the strings, in the vectors, and the box, and some of the others. Like in these data types, the ownership principle will be applied. So I hope you understood that what are the variables in which the ownership principle will not be applied, and what are the variables or the data types in which the heap memory allocation will be applied. So and the heap memory allocation is present in it, and the ownership principle will be applied in these kind of data types. So yeah, I hope you understood. Now let's go to the, what you can say here in this chart, in the Visual Studio Code, in which first of all what I will do here, I will create terminal, write this, and what you can say here, pwd, and let's create another what you can say file here, cargo, new 12, and then ownership, right? Sorry, I have to write the package name, so name ownership. So yeah, now let's take a look at, open this first of all. Now let's write main, delete this, and main sorry. So main, inside this main, what I will do here, I will write a variable called x. All right, so x variable is equal to, like, it's first of all the data type is going to be string, and now let's write the value here, string from what you can see here, hello world, right? So this is a hello world like string that will basically be using the ownership principle, because it is stored in the heap memory. All right, so now let's save this, and if I write like print line x, value of x, you will clearly see, let's say if I go to this 12 ownership cargo run, you will see that what you can see here, x should be defined here. Sorry, yeah, I have not defined x here. So yeah, this is giving me the error. So now you can see here, value of x is hello world. Now it is clearly printing the variable or the data that is printed present inside this x variable. But here is the catch. So basically, hello world is the x variable is the owner of hello world, right? I hope you understood. So this x variable is the owner of this hello world string. Okay, now let's say ownership before taking the ownership. All right, so now this is not taking the so this is not transferring the ownership. So before transferring, let's say before transferring the ownership. So it is not transferring the ownership. Instead, the X is having this kind of hello world string that is only the owner of it. All right, so the X is the owner of hello world. So it is not transferring the ownership. So before transferring the ownership, it will look like this, but after taking the ownership, like after transferring the ownership, what it will do here, I will declare another variable like let y is equal to x. All right, so now y is the owner of x, so it means that the x ownership is now transferred to y. All right, so I hope you understood. So let's say if I copy this, now let's print it like y. So basically what it does is that value of y is now this hello world, and if I print it in front of you, you can see here clearly that the value of x is that before ownership. All right, and the value of y is after taking the ownership. So let's remove this. Yeah, so now if I print this our hello x again, what you will see here, if I print this x again, you will clearly see that the x is not having any kind of ownership now. So now we can see here that the value moved here. So what does it mean? That the value of x or the ownership of x is now moved to this y, and now this y is the owner of this hello world, and x is not the value owner of this hello world, and that's why it has given me this error. Move occurs because x has a type string which does not implement the copy trait, and value borrowed here. So it means that the 12, yeah, so the value is borrowed here, so it means that the value is not used here, although it can be used here because the ownership was not transferred, but now it is not transferred here because now the new owner is the y. So this is what is called the owner. All right, so how you can, let's say if you want to give this ownership to x again, you can make it equal to this x again, but there are other ways also in which you will be taking the reference or you will be taking the clone of it, but I'm not going to discussing in this video, it will be too much, but you need to understand that what is the ownership principle and what is the how you can transfer the owner. Before the x before this x was the owner, but now the y is the owner and x is not going to be printed. That's it. Now let's take a look at the example of integer. So let's remove this, comment this, and now let's comment this again like this. It will give the error. All right, now let's say if I write a int is equal to u8. So now you can see here the u inside integer is 8-bit. So 8 bits is a fixed size. It means that it cannot grow from 8-bit to 16-bit or 32-bit because it is now fixed. So that's why it can be, even if you mutate it, or even if you change the value or append more data into it, it will not be increased until you change the data type here. All right, so this is the point, that the ownership will not be applied here because that is stored, this is stored in the stack memory. So now let's say 45, right? So now after that, let's say if I print this, value of a int, that's a int, and after that if I print like clear this, you will see value of a int is this one. Now after that if I say b int is, what is the data type, and that is going to be a int. All right, so now what it does, it will not move the ownership. Instead what it will do here, this a int will be owning the data, and this b int will also be owning the data, because the data is not moved from a int to b int. Instead the data is copied from A int to B int. All right, so now the A int also having the data, and the B int is also the copy of their data. So now both of them are the owner of the same data. All right, so if I print this like value of B int and now let's say again, all right, so this will be fine. Yeah, so if I take a look at this, you can see here the value of A int is the this is the fixed size. Now the value of B int is also 45, because now the data is copied from A int to B int, and now both of the variable are having the same data, because this is also having the copy, this is also having the copy. Now after that the A int is having the copy, that's why it will still print it. So it will be stored in the stack memory, it will not be stored in the heap memory, because the data type is fixed, and that's why, right? So if the data is fixed, then it will not use the heap memory allocation, and it will also not apply the ownership principle in it. So yeah, that's from the ownership side. That I hope you understood that what ownership is and how you can use it, and this will basically allow you to not cause a lot of memory allocation bugs because of the ownership principle. And I will go deep dive into other concepts like borrowing, referencing, and all of these things, but for now I don't want to make this video too long. So from this video, I hope you like this and understood it. So if you liked it, then make sure to subscribe to my channel, and if you have any questions, then ask those questions in the comment section below. I'll be happy to answer all of them. So till then, goodbye.